As we saw in the last video, the differentiation produces one null space, one dimensional, means in the column vector one would be 0 and the rest all would be non-zero. So that says that d by dt of a naught is equal to 0, and if the polynomial is of n, then the non-zero values would be n minus 1. Then let's see the integration and the multiplication ones. And as seen here, integration from 0 to t of that same equation a naught plus a1t plus a2t square and so on up till an t raised to n. As we know, integration will not cancel, will not make any of the terms 0 for this equation. So it would be like a naught t, because integration of a constant is constant multiplied by t, and the second one a1 t raised to, like a1 t will be there, a1 t square by 2 it would be. That way it goes up till an n plus 1 t raised to n plus 1. And if a polynomial is multiplied by 2 plus 3t, then 2 plus 3t, whatever the multiplications by, when this gets multiplied by 2, the polynomial when it gets multiplied by 2, and even when it gets multiplied by 3t, those all combinations would be present in this result. Then let's see how the problems are solved of this type. What is a linear transformation? What linear transformation takes x1 and x2 to ax1 and ax2 is the question. So what linear transformation takes x1, which is 1 0, to ax1 and x2 to ax2? So x1 is a 1 0 and x2 is a 0 1. So just say the unit vector, 2 by 2 dimensional vectors they are. So ax1, a will be given to us. So it is a 3 by 2 matrix. So we have 3 rows and 2 columns. When the x1 is multiplied to this one, we get ax1, which is nothing but, when we know the multiplication, when this gets multiplied with 1 0, we are going to get only this column. And similarly, when this a is multiplied with 0 1, we get only the second column. That's it. The ax1 and ax2 are these. So when a is given, x1 or x2 are given, so it will not be hard to find this. I hope there is no confusion with this. So just we can write a and write this column vector, just go for multiplication. We know row into column, so we'll get these values. If the values of x's, like if a is getting multiplied with 1 1, if a gets multiplied with 1 1, in that case what we have, so we know that this a is 2, this a is 2 4 3 6 4 8, when it gets multiplied with 1 1, so it is nothing but 2 plus 4, 3 plus 6 and 4 plus 8. So it has to be 6, 9 and 12. The same has been given here. So it is 6, 9 and 12. When it gets multiplied with 2 minus 1, they all go 0. It will be a null space. Means the null space of A is 2 minus 1, we can say. So this is regarding that a simple, like how a into x is calculated. Then we are learning the property, like the differentiation. The differentiation, how does it has to be, like we are learning the differentiation results. So let's see, integration and differentiation are the most important parts, and even we can find the differentiation of an equation The differentiation of, let's say, a given simple equation we can find by using the matrix method. So what all will be the requirements for that? Let's see. So find the matrices. So in order to do that, we have to find first what is the differentiation matrix, and then with that we can multiply and find the differentiation of that particular equation which we are supposed to do. So let's see, once the problem is understood, we can get what exactly is being done here. Now first we decide the basis here. Means we need to know how many number of our vectors should be there, like what should be the order of our vectors, whether it should be R2 or whether it should be R3 or Rn. Now for a polynomial of degree 3, there is a natural choice for the 4 basis vectors. Means if we are constructing the polynomial with base 3, then we'll be having the with degree 3, then we'll be having the 4 bases. The 4 bases polynomial of base 3, how does it look? Let's see. The polynomial of base 3, the polynomial of degree 3 will have 4 base vectors. So what is that? So polynomial of degree 3 means t raised to 3 it has to be. So it will have how many terms? Means basis means these terms, a0, a1, a2, a3 and so on. So this represents p1, p2, p3 and all. So these will be represented p1, p2, p3 and p4. But what are these values of p1, p2, p3 and p4 are? The p1, p2, p3 and p4 are these. The coefficients of each, the coefficients of a0, the coefficient of a0 is 1, the coefficient of a1 is 3, coefficient of, like in this equation, the coefficient like this a0 is multiplied by 1, then this p2, the value of p2 is 3, the value of p1 is 1 and the value of p2 is t, p3 is t square, p4 is t3. So once we know the values of p1, p2, p3 and p4, let's apply a p1. So as we know, a of a p1 we are supposed to find. Let's write it in this way or in a bracket. A p1 is nothing but d by dt of that value, d by dt of p1. What is p1? p1 is 1. When we do differentiation of 1, what we get? A 0. When we do differentiation d by dt of this t, because our p2 is t, so differentiation of ap1, ap2 means differentiation of 2, differentiation of this second term t. So differentiation of d by dt of t is nothing but 1. Similarly, ap3 is going to be, ap3 is d by dt of this term t square. d by dt of t square is going to be 2t. And differentiation of, like, what is ap4? We have differentiated all these p's, p1, p2, p3 and p4. This ap4 is differentiation of t cube, d by dt of this t cube. Differentiation of this will give 3t. t square. So we are writing the same values. The values are as here. So the values of AP1 is 0. Like when we do the differentiation of that equation, we get like 0, 1, 2, t, 3, t square it is. So AP1 is 0, AP2 is P1, AP2 is how much? AP2 is 1. But we know the value of P1 is 1. So this can be written as AP2 is equal to P1 we can write. Then AP3 is nothing but 2t. We know that the value of P1, let's write that, the value of P1 is, the value of P1 is 1. So as value of P1 is 1, we can write this AP2 as the one it is, so we can write it as P1. Similarly, AP3 is 2t. We can write this one as 2 into t is nothing but P2. So we can write this one as 2 P2. And this AP4 can be written as 3 into t square is nothing but P3. So we can write them in this fashion. So it can be written as P3. So we understand now the equation was for degree 3. We have considered the A0 to A0, A1, A2, A3 kind of that equation, and P1, P2, P3, they are nothing but the multiples of A's. So those values would be these 1, t and all, and when we differentiate them we got this equation which is nothing but AP, because when A is nothing but d by dt, when A gets operated on these individual terms, differentiation of 1 has given this all 1 and all, these are represented as AP2 as P1 and so on. I hope this thing is clear. Now d by dt is acting exactly like a matrix, but which matrix? So for that it is a 4-dimensional space, because we have 4 terms here. So as we have 4 terms, let's consider it is a 4-dimensional matrix. Then this 4-dimensional matrix bases are, let's consider an identity matrix. 4-dimensional means if it is a 2-dimensional x and y, like 1 0 and 0 1 would be the combination. Like 3-dimensional means it would be 1 0 0, 0 1 0 and 0 0 1. If it is a 4-dimensional, then the P1 will be, it is a 4-dimensional, just we can consider a unit vector. A 4-dimensional unit vector would look a unit matrix. A 4-dimensional identity matrix would look in this way. It would be 1, these all 3 zeros, and this would be 0 1 0 0 and 0 0 0 0 0 1 0 0 1 0 and 3 zeros and a 1. So this kind of a matrix. Now to this we are writing as P1, it is P2, P3 and P4. Now these are the values like A0, A1, A2 and A3. Now when these are considered, A0, A1, like P1, P2, P3 and P4, when they are being taken, now let's find what is the differentiation matrix. Now differentiation matrix is, when we do, to see how matrix is constructed, let's see this. Now this is P1, P2, P3 and P4. Then what is a differentiated version? The differentiation means what is the d by dt? What is d by dt matrix? The d by dt matrix is equal to what? D by dt matrix is going to be, it's a differentiation we can call, or d by dt, because a operated on those. So differentiation of this one, so it will be representing our first column AP1 it is, the second one would be AP2, these AP1, AP2 and all are written just for reference. AP1 is the P1 multiplied by P1 is this one, the P1 is this column. AP1 is what? When P1 is differentiated we are getting 0, means it will be a column of zeros, 0 0 0 0. What is AP2? AP2 is P1. What is P1? P1 is this one. So AP2 is nothing but P1, means we have to draw, or we have to represent whatever is the value of this P1. So P1 is 1 at the first place and the rest all are zeros. Similarly, AP3 is 2P2. P2 is this one, just it has to be multiplied by 2. 0 multiplied by 2 is nothing but 0, so only this gets changed as it is 0 2 0 0. And similarly AP4 is 3 into P3, so P3 is this one, so the vector would be 0 0 1 into 3 is nothing but 3 0. So whatever the d by d matrix is there, it is nothing but this one. The first one is a 0, because differentiation of a naught, this differentiation of this first one has given 0, and the further ones are as it is. So let's see whatever is our result. The resulting, the differentiation matrix A is nothing but whatever just we have constructed. It is all zeros, 1, 2, 3 in this way. So it is all zeros, 1, 2, 3. It is a differentiation matrix. Now the thing is, we want to do the differentiation of a equation. Let's consider an equation, just our P is equal to, let's say it is 2 plus t minus t square minus t cube. Let's say the P is this much. When we do the differentiation of this, we know the result. So in order to do the differentiation, we know the result that when this is differentiated, 2 plus t minus t square minus t cube, when it is differentiated, let's see, when this is differentiated, let's write 2 plus t minus t square, 2 plus t minus t square minus t cube dash minus t cube. When this equation, let's call it as P, when this is differentiated, it is written as, let's say differentiation is d by dt of P, d by dt of P is equal to, we know differentiation of this one, 2 is a 0, differentiation of a t is 1, then this would be minus 2t and minus 3t square it will be. We already know the result, and if we are writing, we can write it in what way? Let's see how does it happens with the matrices. Now this equation is multiplied, means to do the differentiation we are using the matrix, and this matrix is nothing but representing, it is a d by d or a differentiation it is. So differentiation matrix. So this differentiation d by dt of matrix is taken and it is multiplied with p. So what is our p? It is 2, 1, all the coefficients, -1 and -1. When these are multiplied, we know when these are multiplied we know the matrix multiplication, so rows and columns. So the first result is 1, second result is -2, third result is again -3, and last we get zeros. So which is nothing but 1 minus 2t minus 3t square. The same is being reflected here. So it is 1 minus 2t minus 3t square, and this will be written at last. So this is the differentiation method. So the same way it is written, but the 0 is written at last. So this is regarding the differentiation. The next things we can learn in the next video. So this clears how the differentiation happens. Differentiation of this one is nothing but 1 minus 2t minus 3t square. The same is being proved by the differentiation matrix. So this is the next class. We'll see what is integration. Let's stop it here.